Hello there. I would like to talk to you about a particular feature in the R9 controller called the External Control Interface. The External Control Interface allows you to send commands externally over Ethernet, simple text commands for the controller to interpret and act upon. For example, you might be able to use an external program such as LabVIEW, MATLAB, or Java, or C++ to interact with the R9 to change operational parameters. For this example, I'm going to show how to set up and send some external commands using a pre-built external application to control the center frequency of my PLL. And what I'll show you is the delta F on an oscilloscope that will also update as I send the command, so you can see that it actually has a real effect. Okay, let's get started. So, in order to use the external command interface, when you're in the shutdown condition, you have to add a new item to hardware space called the external command receiver. So you can access this by typing ext in the search bar on the item palette in hardware space to see the external command receiver. We'll then place it on hardware space, and as you see, it has a port associated with it. Its only properties is the port. What this is it's the port that we're going to send text commands over Ethernet to for the R9 to parse and act upon. So I've already initialized the controller, and I've already made a frequency sweep and set the PLL to match the center frequency of my tuning fork. Actually, to be fair, I'm 2 hertz off of the resonance, which is why my delta F is -2 hertz. Okay, so my external application, I have the IP address, which is local, I have my port, which matches what I had in hardware space, and I press connect to server. Now I'm connected. The external command interface has a particular command format which can be found inside your documentation. So for this example, you can see I'm going to send a single command in this field. Another option for testing is you could make a batch of commands into a file, and then you can select and send the file as a whole. And that way it will send the commands in sequence one after another. But for this example, I'm just going to send single commands. Okay, so our command string here, set hardware subparameter. So the hardware piece is the PLL, the parameter is the reference frequency. I'm going to change the value. And here I have my standard unit in hertz, so 32.767767 kilohertz. So what I'm going to do, I'm going to come over to the 1 digit. Let's change this to a 9. Oh, let's go up one. Let's go to 6. When I send the command, it updated the center frequency on the PLL here. And now you can see that our delta F also changed by 1 hertz. That was fun, wasn't it? Let's do it again. There you have it. So something you could use this to do is possibly compensate for drift of your resonant frequency that's happening external to other things in your system. So this is external to, or independent of sample thermal drift, for example. This could be caused by, so a delta F drift could be caused by, for example, your laser heating up your cantilever. So in this case, somebody could write a script to retract the tip, read in the current delta F, then figure out what the new center frequency should be, set that as the new command being sent. The delta F would now go back to 0. They could enable feedback again, wait a little bit, and then continue the experiment. Let's change that one more time just so you can see that this is happening. And just like we saw, it changed here. Well, Hopefully that's a good, very quick introduction for you for how the external control interface works. If you have any other questions, please contact me at support@rhk-tech.com. Thank you for watching.